So we know that we have these equations, and they satisfy x squared plus 27 is equal to negative 8y plus 10z. And then y squared plus 196 is equal to 18z plus 13x, and z squared plus 119 is equal to negative 3x plus 30y. You want to sum them up. That's an excellent idea, but let me ask you, why would you want to add them together? So the important thing to note is that we have these expressions, x squared, y squared, and z squared. And then we have these. So first of all, if we work on each equation one by one, we can't even solve for one variable in terms of one other because each of these equations has three variables. And then also notice that if you can combine this x squared with this 13x and this minus 3x somehow, then the other terms, y and z, they won't have to worry about that x term anymore. So if we add them up, what we can do is we can combine each variable with its, we can combine the quadratic term and the linear term of each variable. So if we add them, we get x squared plus y squared plus z squared plus, and this is going to be 342 is equal to 10x plus 22y plus 28z. So now we have this expression. It doesn't look that good, but admittedly, it does look a whole lot better than these three. So we have three variables here. And then there's no way for us to solve it. And we can't factor the whole thing together because they're not even symmetric. Like this in 10x, this in 22y, and this in 28z. So we can't really factor them all together because then we're going to have something that that's not even symmetric. So let's see. We can't really factor this entire expression, so it's no use factoring 342. Even if we find it's perfectly factorable, we can't really combine them with the other terms. If we can't factor all of the terms together, we can factor each individual term. And if we want to do that, first we got to combine them, right? So this is x squared minus 10x plus y squared minus 22y plus z squared minus 28z equals negative 342. Yes, exactly. That's exactly right. Finally. So now, once we have this, it looks suspiciously like the factorization of a perfect square. So let's see if we can just complete the square for all three terms like you suggested. So first let's add 25 here, because that's 5 squared. And then we add 121 here, and then we add 196 here. So then we get x minus 5 squared plus y minus 11 squared plus z minus 14 squared, as you said. So now on this side, we get minus 342 plus 25 plus 121 plus 196. And what is this going to be equal to? Well, this is 0. It's exactly 0. So now we have something that looks really nice. We have x minus 5 squared plus y minus 11 squared plus z minus 14 squared is 0. So what do we do now? We know that. What do we know about perfect squares? What do we know about perfect squares? We're not going to take the square root because we can't take the square root of each expression at once. But what do we know about squares? What do we know about these squares? Remember, this is an important property. Every square is greater than or equal to 0. So let's say we have a number n, and n squared is always going to be greater than or equal to 0. It's never less than 0. If it's positive, then n times n is positive. If it's negative, n times n is also positive. And if it's 0, it's 0. So n squared can never be negative. But the thing is, if we take 3 inequalities, x minus 5 squared is greater than or equal to 0, y minus 11 squared is greater than or equal to 0, and z minus 14 squared is greater than or equal to 0, and we add them all up, we get this sum is always going to be greater than or equal to 0. And the thing is, they're only equal. These are all equal to 0. The squares are only equal to 0 when x minus 5, y minus 11, and z minus 14 are 0. So if all of these numbers are positive, or not all of them are 0, then this whole thing is going to be always greater than 0. So if we want this whole expression, this whole sum, to be equal to 0, then every one of these terms has to be 0. Therefore, we can say x minus 5 equals 0, y minus 11 equals 0, z minus 14 equals 0. So then obviously we can solve and get x, y, z is 5, 11, 14. So now we want to find x plus 3y plus 5z, and we can easily evaluate this as 108. So the answer is 108. So do we have any questions? Okay, do the last part again. So if we add these, the sum is greater than or equal to 0. So then equality is only achieved when all of these are 0. So x equals 5, y equals 11, and z equals 14.